So what we're going to do in this video is complete the first lab, and it'll be for you to yeah, okay, so let's go. So don't need this, don't need this. So we want to go with this. So the way it works, it'd be equal to 20 plus 80 times exponential of, and then minus 0.07 times t. And then I can, if I just press this, it'll go the whole way down, and you get what this is. There's a question there about what might this be modeling, and what might the units be. In my head, this would be the temperature of a cup of tea in minutes. So you make a cup of tea and it's initially boiling temperature. After 10 minutes it's down to 60, and then it just keeps reducing down to room temperature. That's what I had in mind. Okay. Second one, here we go. So the V is equal to 36 minus 12 times X. Similar story. The M is equal to 6 times X squared minus 36 times X. And then do the same thing. Possibly should have used the smaller, what we call step size, the difference between those. Select them all. Insert, graph, and this thing. Now what this is actually called, you can have a think about what this represents. I understand you would have seen something like this before. This is a bending moment diagram for what I would call a constant load, but you probably call it uniform constant load on simply supported beam. So the load is across the beam is the same. It's 12 kilonewtons per meter. The span of the beam is 6 meters. Then this is the shear, which we don't have to worry too much about it. But where the shear is 0, the bending moment is 0. But the bending moment actually is positive, but the way the engineers do it is they plot it upside down. Okay. The third one. So let me see. So if I solve this little equation here, I would get multiply both sides by omega. I'll get 20 omega is equal to 2 pi, and then I would divide both sides by 20, and I'd get omega is equal to 2 pi over 20, and I can divide that above and below by 2 to get pi over 10. So the omega here is pi over 10. Now, if the period is 20, that's how long it takes for a full cycle. So if I want 3 cycles, I need to go up to 60. Now maybe I'll go up in 0.5s. And I need to go up to 60 to get the 3 cycles. Now that might have been a trial and error situation for you. There we go. And there we go. So equals to the amplitude, which is 10, times sine of omega, which is pi over 10, which we'll fix that in a minute, pi over 10. So to do pi, you do pi like that, over 10 times x. Now you might have a bit of a worry here about the brackets and everything. So if you're not sure, you could put extra brackets around the omega, the pi over 10, and then you're going to have no problem. Times x, and then the phase you can just let be 0. I might just put a little thing in there. Okay, and then I can select both of these, insert, get a nice graph, and I can see 1 cycle, 2 cycle, 3 cycles done. Okay, next question. So I think, did we do the first one? Give me a number, say 5.67 multiplies by 10, done. Okay, the second one, I don't think this is finished, no. So developer, view code, and we're working this one. So there's 2 inputs here, forename and surname. So we've got the first one, then we do the second one. Surname as string. Okay, make the program ask for an input. So 2 pieces of input, 2 input boxes. So str forename equals to input box. I'm just going to use, okay, what is your forename? Question. And then str surname equals input box what is your surname? Okay, that will provide all that. Produce the output with a message box. Message box. Hello. Now I want to get the spaces, so I can actually put a space there. And str forename. And I need another space here. And str surname. And hopefully that works. So forename JP, surname McCarthy, hello JP McCarthy, happy days. Okay, so this one, two variables, so I can do dim dbl f as double. I think can we do a comma and then do another one, dbl c as double. Yeah, you can do it like that if you want. Ask the user for input, so that would be, the input is the Fahrenheit, dbl f equals input box. What temperature in Fahrenheit would you like to convert? And then calculate the temperature in Celsius, dBLC equals. So the 5/9, now I could do 5 by f minus 32 divided by 9, but if I want I can maybe just do 5/9 times dBL f minus 32, so that's going to convert what I did. So here's the number I give it, and then it's going to calculate the dBLC, and then the output box be, well, there's no such thing as an output box, we call it a message box actually. Output box would be a good name for it. Let's say the temperature is, now I need to put the dBLC outside here. Outside this, because otherwise it'll just be considered a string. So here we go. So like you always hear them in Florida, it's 102 degrees. What's that? 38, so it's quite warm. You could maybe worry about, could we reduce the this thing? You could, if you wanted, you could use a rounding function from Worksheet. Maybe I'll do that here. So does that work again? Pause for a second. Now what did I have to do there? I want to use a rounding function. I googled it because you just can forget, and that's fine. So how you use something that you know works in Excel is you do worksheet function dot the function you want round, and that has two arguments: the number you're putting in and the number of decimal places. So that will be if you want to get a bit of rounding, and maybe even throw in a bit of Celsius. We'll just put in a C for Celsius. Say it's 106 degrees. It's 41.14, 41.1 Celsius. Okay. The ifs and the elses. Okay, so define a variable x, dbl x dim dbl x as double. Okay. Ask a user for an input. That'll be dbl x equal to input box. Give me a number, please. Okay. So loop. Oh, sorry, that's just a thing. So if dBLX is negative or dBLX is bigger than 10, that's no good. That'll be a message box saying, the question says no dummy. Okay. Now, will this next bit work is the question else. If dBLX is bigger than 0 and dBLX, and so here there's something wrong here. So else if, yeah, that seems weird. Okay, I think there's another one where you do like, don't worry too much about it, you'll get something that works anyway. So if it's between those, I think it's 2, this is not enough. I think you can actually leave out these brackets on MsgBox, but it's good to think of putting inputs into brackets. So the other one then is else if. The other condition is if it's bigger than 5. Now you can be a little bit smarter here. So you could do bigger than 5 and less than or equal to 10. But because you've actually already ruled out bigger than 10, you just have to do bigger than 5. So sometimes there's some of these you can do that. So if dblx is greater than 5, then and the question is, does it go? We'll test this in a minute, so we'll see what happens. Does this actually work? I think it does, because if you put in 11, I think it does this, and if it goes into one of them, it just goes to the end if. But we'll find out soon. And the MsgBox is, this is too much, is it? Yeah. Else if, then the other one. Can we just do else? Because there's only one possibility that it's 5. MsgBox. So we might get errors in this, then we'll figure it out. Is it just right? Spot on or something. Okay, and then end if. Like now we'll go through this line by line and we'll test it in each of the different ones. So F8. Okay, so we'll start with a negative number. What does it do? It gives us no dummy. Now does it go to the end? It goes to the end, so we're fine. So each of these is just saying if the thing, if it hasn't before put into one of the categories, it's just going to go. If it's already been in one of the categories, it's going to go to the end of the if. So the next one would be, say, 2. So that's in there, so it does not enough, and then it goes to the end if. And then the next one I might try, we'll just do F5 now. So 6, too much. 11, no dummy. And then finally, on the money, 5, spot on. Okay. So you could have written a bit more there and still got the same thing, but you need to probably test it on all of those. Okay, next one. Prompts the user for a whole number, which means for us an integer really. If the input is a multiple of 2, return the same number. If the input is odd, return twice that number. You might need the code a mod b. Okay, so the variable is, I'm going to call it n for an integer. So dim int n as integer. Started off, int n is equal to, it's going to be an input box, isn't it? Yeah. Give us a number. Okay, that's the input box. And then the if loop. So if, now this is how you test if something is even. You do the number mod 2. So if int n mod 2 is equal to 0, that means when you divide by 2, the remainder is 0. That means it's even. Then what do we do if it's even? Return the same number. MsgBox int n. If you put the this around it, it makes it a string, and it won't give the number you gave. It'll just give the symbols intn. Else, well, otherwise, if it's not even, it's just going to be odd. Now you might mess around with what if you don't get a whole number, but I won't worry about that. Else MsgBox twice int n. End if. Okay, we'll give this a go. So F5, give it 4, it should give the same number. And give it something odd, it should give us twice that number. Let's see what happens if it gives us, say, 1.5, which it shouldn't really take because it's supposed to ask for a whole number. I don't know what it did with it. Did it round it up? Let's say 3.4. Does it, maybe it'll give us 6? Yeah, but you could put that into the code that it has to be, yeah, how you do it exactly, I'm not too worried. You can Google and say, how do I make sure my program only takes whole numbers? Yeah. Next one. So we'll go back to the sheet. Are we on the ifs and elses? We are. So exercise 2, exercise 3. Right, so this one, you want to get a whole number. then prompts the user. So let's kind of think of that. So it's going to be variables. This is the basic setup. Variables, initial values, loops, more or less. Okay, so prompts the user to input a whole number. So that's an integer. Now we are going to, yeah, we'll just say it's, again, if you really want a whole number, there's probably some other code you need to put in, but we won't worry too much about that. So dim int n as integer, that's the whole number. Then prompts the user to input a decimal number that approximates the square root. So you try and do the square root of this in your head. Now the square root of a number is not going to be a whole number, it's going to be a decimal, so this must be a double. So dim, we'll call it dbl root, we'll call it s for square root as double. Okay. The initial values, so both int n and dbls come from they're user defined, so they're input boxes. So int n is input box give us a whole number. Then dbls input box please guess the square root. This would probably have to be a positive whole number. So like you can kind of, you know, if int n is negative, you can say go back to the start, and you can Google how to do that. It's not too important for us. Please guess the square root of, I'm going to call this n here. So please give a whole positive whole number n. Please guess the square root of n. Okay. If the distance between the approximation and the actual square root is less than 0.1, a message box says, good guess, with incorrect, otherwise try again. Okay. So this is going to be an if. So if, now the distance between numbers, you do one minus the other and make it positive. So it's the absolute value of the difference. So ABS, if the difference between EBLS, which is what you guess to be the square root, and the square root, which is SQR in VBA, which is weird, of int n is less than 0.1, then you can do the message box for good guess. Good guess within 0.1 of the correct answer. And then else, so if the distance between your guess of the square root and the actual square root is too big, you're going to get message box, try again, you were a distance, and now we can get the distance from, now if we're doing strings here, so we're going to do an and. So the and in here we're going to put the distance, so the distance we can just get. Your distance, oh wait. Okay, let's play with this. Block without end if. Yeah, great. Okay, and that's actually what happened there. Like, there's nothing more is going to annoy me when you submit VBA that, like, there's an error like that you could have just fixed yourself. Okay, anyway, positive whole number, the square root of 5, how about 1.7? Close. And I see the space issue, and you see how long it is, so maybe we'll go back and actually fix that. So the space issue, I can put in it there, and I'm going to round this by doing the worksheet function. Worksheet function dot round, and I'll go to 3 decimal places here. Okay, let's try again. So I think we tried 5, we tried square root 1.75. Try again. Oh God. 5, 1.65. I'm being very stupid. Sure, the square root of 5 is bigger than 2. Good guess. Okay, very good. Right. The 50s along the diagonal, we did. There they are. Next one, do a loop that displays a message box displaying hello 3 times. Okay, so here we go. So how are we going to think about this one? It's going to be message box, message box, message box, but we must keep a count, so we need a counter. So I need a counter, dim int c as counter. Okay. We're going to give initial value c, 1, and then we're going to do the loop. So do a message box that says hello. So it's going to do it on the first run when the int counter is 1. Then for the next run, we want the int counter to go up by 1. So int c equals int c plus 1, so it goes up by 1. And then loop. Now we could do until, but I'm going to recommend always bigger. So until the int counter is bigger than 3. Now you might have put in 2 or 4, and you might have to just test it once or twice. Yeah, counter is not, so that's integer. Hello, 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 very good. Okay. Write a loop that outputs 10 random numbers in a column. You may need to use random. So here what we're going to do is, and I'll probably talk us through this one. We'll pick a column, and maybe we'll go to column X here, okay? Or maybe something that's a bit easier. So if we go to, well, it just says any column, so we can just start here, say. That's row 10, column 1. That's where we're going to start, okay? Row 10, column 1. Yeah. So we're going to need a counter. Need a counter. And that's what that's going to do, is it's going to count us down the rows. So we're going to go a random number here. I'm just going to put in ones. Random, well, maybe I'll start at 11 just because it'll be 11 to 20. So 11, 12, 13, 14. We need to do that. Okay. So what we need is the loop that basically says, okay, we're going to start here, and we're going to print in a random number here. And then if the counter isn't too big, we're going to go to the next row and print another one. Now the thing, what we can do here is we can actually think of the counter as actually the row number. Because look what we're doing, we're going from a row 11 to 12, 13, 14, 15, up to until it's bigger than 20, in which case we're going to stop. So I'm not going to call it actually int c, I'm going to call it int row. And I'm going to start it off, this thing in row 11. Int row equal to 11, so that starts it off. So now in the loop, okay, so do cells, now put in the row and the column is 1 equal to the random number. Now we're always going to have this, we're going to see this more and more later on. So print next value. So it's define variables. This is the thing that will get you through. Define variables, then initial values of the variables, and then in the loop you print, and then you calculate the next value. So the next value is you put the row number up by 1 to bring you to the next row. And then you loop until the row number is bigger than 20, in which case you'll stop. Okay, and to see how this works, we're going to go through it with F8. And we're going to keep an eye on our worksheet at the same time. So F8, okay, so F8, F8, intro is 11. So if we go on this, we see that the row number is 11. 2. So this is going to be cells 11, 1, that's row 11, column 1, equal to a random number. We're going to see it if we press F8, boom. Now there's not much, there's a lot of rounding here, but don't worry about that. Then it's going to put the row from 11 up to 12. Is the row number bigger than 20? No, so it loops. So now the row number has gone up by 1. So now we're in row 12, column 1. boom, up it by 1. Is it bigger than 20? No, loop, and keep looping and looping and looping and looping and looping and looping until you're finished. And then there's probably a bit more precision in these that you couldn't see. Okay, I think that's everything in your first lab. So if you haven't produced the what you wanted to produce, and you're still not sure, or you're trying to do it another way and it's just not working, what you're going to do is you're going to be submitting your VBA code on Canvas, and I'm going to go through your code and fix it. So that's what we're going to do.